Okay, if you recall, bright line spectra are is the light energy produced when electrons from an excited state move back to ground state and release energy in the form of light. We can use a spectroscope to determine what lines or colors make up that light. From that, we can use it to identify the elements. In order for two elements to match, they must have the same spectral lines. So if we ever are provided with a mixture of spectral lines and we know the reference point for each one of those elements, we can determine what elements are present in a mixture. It'll be easier if you see a question. So here we have a diagram which represents the bright line spectra of 4 elements and the bright line spectrum produced by a mixture of 2 of these elements. Here is the mixture that contains the 2 elements in question, and we're trying to figure out which elements make up this mixture. In order to do that, all you have to do is match up the lines of the mixture with known reference lines. Once we do that, it becomes easy to figure out which elements comprise that mixture. Okay, I'm going to highlight the elements in the mixture with what they match up with. So look at these cyan lines and notice that these cyan colored lines match up with the barium element. Also, these red lines match up with the same lines as lithium. Therefore, the mixture must contain barium and lithium in the mixture. Let's try another problem. The bright line spectra produced by 4 elements are represented in the diagram below. Given the bright line spectrum of a mixture formed from these 2 elements, which elements are present in this mixture? Once again, look up the lines making up the mixture and match it up with elements provided in the question. We see that the lines from element A as well as element D match up with the same lines as the mixture. Please note that you're matching up the lines as they appear on the wavelength scale with what they appear in the mixture. So notice these two lines also appear in the mixture, as well as spectral lines at 670 here with this 670 here, and every one of these match up with the mixture. Therefore, the elements A and D are both in them. So again, if you can match up lines within and compare the lines within a reference point to the lines in the mixture, these problems become very simple. Okay, it says explain why the spectrum produced by a 1 gram sample of element Z would have the same spectral lines as the same wavelengths as the spectrum produced by a 2 gram sample of element Z. Well, remember, in order for elements, all the elements' spectral lines are unique to that element. So whether or not we use 1 gram or 2 grams won't matter because the bright line spectra will be the same. So to answer this question, bright line spectra is a chemical property unique to each element's electron configuration. So changing the mass will not alter the spectral lines. Regardless of whether or not we use 1 gram or 2 grams, the spectral lines will always be unique to that element. Let's try another problem. Which element is not present in the mixture? Once again, if you can match the lines from the elements to the lines in the mixture, you can figure out which element is not present. Okay, you should have noticed that the lines in element X are not present in the mixture. Therefore, the answer is 3. Last problem. State evidence from the bright line spectra that indicates element A is not present in the mixture. Here's the mixture, and here are the spectral lines of all the different elements. So you simply have to figure out why element A is not present in this mixture. You probably noticed that element Z's lines and element D's lines are present in the mixture, but element A's spectral lines are not present. Therefore, the mixture contains the same spectral lines as element D and Z, but does not contain the spectral lines from A. Therefore, it cannot contain element A in the mixture. Remember, spectral lines are used to identify a specific element within a mixture, and every element has unique spectral lines produced from that element. Therefore, to determine what's in the mixture, all you have to do is match up the lines from the mixture to the reference points. If you can do that, these problems will become incredibly simple. I hope this was helpful, and thank you for watching.